seen all these applications of ray tracing for different analysis purposes, and I was kind of curious what kind of things we could do with adaptive components to just do a really simplistic kind of ray tracing. And I've made this family, which I just called bounce over here, which does a single bounce of basically of a ray into an environment and then off of a surface. So that the way it works is that and then this is my sort of simplified band shell, which I'm going to sort of do a quickie analysis of to see whether or not somebody speaking here in the center could bounce their sound waves out into the audience. And we'll go into this a little bit more, but so what this thing does is that I can pick my source and I can pick some environmental surface, and when I hit it, it basically reflects the point off in a manner that a bounced ray would. I can start using this to analyze surfaces. Really simplistic, single bounce, not a whole lot of computation involved in this. But I'm going to go through how it is that you go and make this family, because it gets a little bit involved. So what we can do is we can open this family up and dissect it a little bit. I'm going to open it for edit. And we see we've got an adaptive component that is just a two-pick family. Pick 2 for the target and pick 1 for the source of the ray. And then it has offset from it a point. And then you'll see that there's actually a nested family in here, which if I can tab into it and select, where is that guy? There it is. So there's a 3-point family in here. You see 1, 2, 3. And what this is actually a nested curtain panel family. So you can see we've got our black line that was our original line, and then our green line, which was our bounce. And if I open up my curtain panel here, you'll see it's got more geometry in it. If I go edit family. So in my curtain panel, I've got 2 angles. One that basically is the angle from the target coming into the surface that it impacts, and then coming out from it there is the ray, the bounced ray. And there's 2 angular parameters, one that measures the angle from basically a normal line coming out from that impact point, and then another one that reproduces that angle. And you have to do this in curtain panels, because curtain panels are the only thing that you can actually do a strong reporting parameter between an angle. So we will go and make this from scratch. But what happens is that if you take this thing and you load it into your first adaptive component, you actually place the curtain panel inside of the adaptive component, and then your adaptive component becomes a 2-pick family, and we'll get into that from scratch. So first thing we're going to do is we're going to go new family, and we're going to make a curtain panel pattern based. It starts off with a rectangle. We're going to take this rectangle by selecting this grid, and we're going to turn it into a triangle flat. Triangle bent has 4 points, triangle flat has 3 points. So there's our triangle, and we're going to create a work plane that we're going to operate on. And we're just going to select all 3 of those lines. We're going to create a form. And just going to show you that that's a plane that's defined by 3 points. And we're going to need that planar element. And I like to just make these things disappear so that they're not quite so obtrusive as I'm working on it. I just turn it into glass, and then I'm going to set this to be a not visible material over here in its properties, so that when I load it into another family I don't actually see this. That way it sort of behaves like a work plane. So I've got point 3, this is point 2, this is point 1, and I'm going to say we're going to do it right here. That what we need to do is we need to create a line that goes from point 1 to point 2 and then bounces out at the same angle that you have between line 1, 2 and line 2, 3. So I'm going to show you quickly how to do that. So I've got, I'm going to take a model line. It's not 3D snapping, so I'm going to unclick 3D snapping. I'm going to set the work plane to this new sort of invisible work plane we have. So I'm drawing on this work plane, and I'm just going to go start, and I'm going to go way out here because I want a nice long line to bounce. There we go. And I'm going to add an angular dimension, and I'm still on that work plane, right? So I'm going to do an angular dimension between the reference line and the reference line, and between the reference line and my model line. Now this one becomes a reporting parameter because I just want it to tell me what the angle is between this guy and this line and this line. And again, the reason that you need to do this in in a curtain panel is because in order to make a nice strong reporting parameter, it has to be basically to sort of these baked in elements, and these reference lines are the baked in elements. So I'm going to call this angle 1, ang1. And it's going to be an instance parameter, it's going to be a reporting parameter, and I'm going to use it to extract values from a geometric condition and report it to a formula as a schedulable parameter. And then I'm going to take this guy and I'm going to set it to just another angular value, ang2. And it's also going to be an instance parameter because it's going to get driven by this angle 1. So up here, if I go and I set angle 2 to be equal to angle 1, OK. Now I've got this thing that's basically mirroring this angle. And if I change this guy, I can see how it adjusts, and you can see that these guys are both reading out at the same angle. Right? Now, the plot thickens. New family. I'm going to make an adaptive component. So this is part 2 of this project. So what I need to do is I need to make a 2-pick adaptive component family. 1, 2. Doesn't really matter where I put those down. I got my points. I'm going to make them adaptive. Now what I want to do is I want to have a pick for my source of my ray and then the surface that it bounces off. Now the surface that it bounces off is very important because I need to measure what the normal angle is from that point on the surface. And so the way to do that is I get a point element and I'm going to set my work plane to basically to the normal plane of this point, which is that horizontal guy. Bam. And I'm going to put that point right on that plane. So we can test that out. I'm going to select that point and we're going to see that my point moves around with it, right? Well, if I select those guys and I connect them with a spline by point right up here, now I've got a line that this point is always going to, this line is always going to go straight off of whatever surface I load it onto. And I can actually even go like this, just to sort of give myself some more things to see. And I can test this out in the family that I was already playing around with. So I'm going to load this back into my band shell element here. So now I've got my 2-pick family, and I can just pick out in space somewhere here and pick on the surface. Now it's doing something slightly different than what the loaded family is that I already have. What this is doing is that I have 1 to 2 being connected, but then this guy is just bouncing off normal to this surface. That is, it's at a point of tangency with this surface. And that's not quite what I want. What I want for a ray bounce is that I want something that hits the surface and then it reflects off. It's actually going to be reflecting off in this direction as a mirror of the line over this normal line. So how do I get that? Well, I've got my mirroring of my line here. I'm going to load this into my adaptive component family, like so. So now I've got my now I've got my curtain panel loaded into my adaptive component, and it is family 4. So I'm going to take this guy, and I think I've got my order here right. It doesn't really give me much information just looking at it, but if I go pick on point 1, pick on point 2, and then I pick along the line like that, what I'm going to have is I'm going to have a line out here that mirrors the placement of this one. See, as I move it in, it's always going to basically be the same angle here as the same angle here. And then what my adaptive component gives me is it gives me that normal line coming off of the surface. So if I take this and I load this into my project, into band shell, what we'll see is that we've got 2 lines here. So I've got connecting 1 to 2 And then I've got that normal line. But then I also have this line which comes off, which is the reflection off of this surface as determined by a mirroring off of that normal plane. And that's what these guys are. The difference with these two families is that I've taken this line and I can just get that guy and either make it not visible, or I can turn it into a reference line so it won't show up anymore. Then if I load it into the project, back into the band shell, overwrite the values, that guy just disappears, because what I want is I want that reflection line. I don't want my normal line. And then I've done some other sort of fancy things here where I've just taken this line and I've changed how it's represented. I can also just show you quickly how to do that. So if I go back into here, I can go into object styles and I can add a new subcategory, which is going to be, call it reflection. So I'm just going to call it reflection, and I'll just change the color to green. Oh, here for our purposes we'll do it as red, for instance, and I can make it a dashed line. Okay, and that's going to be this line, and I can just set it to a different subcategory here in identity data, so I'll call it reflection. And then I've got my nice little dotted line. I can load it back into my project. And my adaptive component will have that dotted line like that. And I can load it back into the band shell. And then I've got that. Overwrite both. Yes. Somehow it came out green because it probably has the same name as this guy. Anyway, so here I've got my reflecting points, and I've just got a few of them on my surface. So what can I do with this thing? Well, I can take these guys and I'm just going to multiply them all over my surface here. So I'm going to hold control and drag, and then that's just going to start reproducing these points all over the surface, and it's kind of random. In fact, it's totally random. But I'm going to just make myself a bunch of these points all over here just to give myself a bit of a random distribution of sampling of what this ray is going to do when it bounces over the surface. And let's see, that starts to look like, well, it's not a huge sampling, but I can keep doing this. I can keep reproducing these points. If I just select all of them and then just control drag, I can get a nice distribution of points all over my band shell surface. Oh, I was going to think about that for a second. And I can start to imagine what's going to happen if I have a shape like this and I have somebody talking in the middle of it. That right now this is a lousy band shell, right? Because what it's doing is I've got somebody speaking in the middle here, and all the sounds are bouncing off of this surface, and then they're bouncing straight back down. They're not going out into the audience. So I can just go in here and I can edit this guy. So I can select my surface. Oops, I selected a bunch of things there. I can select my surface, and I can edit the profile, and I've just got a little elliptical profile here to create this surface. So say I just bring my ellipse back in like that. Let me grab it like that and flatten out my ellipse. Let's try that and just see what that does to my ray bouncing. Close out. It thinks about it. It reassesses what all those ray trace lines are doing, and ta-da! Now I've got something that actually projects the sound from that point off of that surface back out into the environment. Again, I don't really know crap about acoustics, but I think that this is a reasonable approximation of what something like a sound wave would do when it was bounced off of a reflective surface, just to give you sort of a general idea of whether or not this is a decent surface for it, or something that was deep would not be a decent surface for it. Anyway, I'm unencumbered by real knowledge about how acoustics work, but you can try out this little ray bouncer and see if you can find any other applications for it. And I've got some more posted on the blog. And I hope that was enjoyable.